Alright, so today we're starting 1-4, which is scatter plots and lines of best fit. So our first definition is a scatter plot, which shows the relationship between two sets of data. So I'm going to make a scatter plot. You don't have to copy it down because it's a little intense, but you do have to make sure you understand how I'm using the information on the scatter plot to answer the questions. Okay, so this is our scatter plot. And it is comparing the highest daily temperature with the number of people that come to the pool. So they're trying to see, is there a correlation between how hot it is outside and how many people want to use the pool on that day. So then after they give us this scatter plot, they're going to ask us all these questions about it. And the first one is, how many people were at the pool when it was 91 degrees out? So I'm going to look at 91 degrees and how many people are at the pool. Yes, good. So 450 are there when it's 91 degrees. All right, so the next one, find the mode of the high temp. So remember, mode is the most. So which temperature do we see the most on our data? That's people. So look at the bottom numbers to see which temperature has the most dots. So I see, I see 4 dots right here. So 86 is going to be our mode. And this is not degrees. Okay. Find the range of the attendance. So this one's a little bit tricky. So we're going to assume that this low dot is 25 people because it's not all the way down on 0. And then the highest dot we have is at 500. So to find the range, we're just going to subtract the highest amount from the lowest amount. So how much is that? Yeah. So the range of attendance is 475 people. And then the last thing, find the median. That means find the very middle value. So of people. So between
it's in between 85.
So you're close. It's going to be, hold on. Okay, so the median attendance is 350 people. So when we're talking about scatter plots, there's 3 types of correlations that we can have. We could have a positive correlation with the data, a negative correlation, or no correlation at all. So a positive correlation looks like this. The data starts low and moves up high to the right. Okay, so it generally has a flow that moves up and to the right. That is a positive correlation. And what that means, remember, this is always your x-axis and this is always your y-axis. As the x value increases, the y value increases. So everything increases on positive correlations. So a negative correlation is going to start high up here, and it's going to go low. And notice the data doesn't go like in a perfectly straight line, but the general flow of the chart is down and to the right. So as the x increases, the y decreases. Correlation means that your dots are literally all over the place. It's just like the whole entire graph seems to be filled with dots. It's not going up to the right. It's not going down to the right. It's just everywhere. Okay, so there's no apparent flow to the data. Everything's just everywhere. And that means the data doesn't really have any relationship to each other. A common example for this type of data is your age, comparing your age to your hair color. Okay, does hair color have anything to do with age? No. So a graph comparing those two things would look like this, no correlation at all. Okay. All right, so the last thing today is line of best fit. It's a line that approximates the trend of the data. And we use a graphing calculator to find this line. So we are not going to be finding line of best fit, but it is in your textbook and on IXL, so you need to know what it means. So basically what it is you put in all this data into your graphing calculator, and it gives you an equation of a line that kind of goes right through the center of your data. All right, and so usually it'll look something like this. It's kind of the average of all your data. Okay, so we're on page 22 in the book, and you need to look at the book for these questions. We're going to do some examples because there's a scatter plot that we're going to use to answer these questions. So the scatter plot is the above average temperatures and rainy days each month. The left side is the rainy days, and the bottom are the above average temperatures. So number 1 says, during the month that had 6 days of rain, how many days had above average temperatures? So look at the month that had 6 days of rain. How many above average temperature days were there?
I'm looking past 6, right?
So you're looking, rainy days is on the side. So find the 6 on the side and follow it across till you see the dot. 8. So there's 8 above average temperature days when the month had 6 rainy days. Okay. Number 2, find the range of days with above average temperatures. Yes. So what is the lowest above average temperature? I see one at 1. You see the dot above 1? Okay, and then what's the highest dot for days above average temperatures? 8, 9. You see the dot at 9?
I'm looking above.
So Bradley, you're looking at the side numbers. You got to look at the bottom numbers. So if we're just looking at the bottom, the lowest is 1 and the highest is 9. So to find the range, we're just going to subtract. So the range of days with above average temperatures is 8. Number 3 says, find the mode of the number of rainy days each month. So now we're looking at rainy days, the numbers on the side. Which row has the most dots in it? 7. Yeah, 7 is the only one that has 2, right? Okay, so the mode is going to be 7 for rainy days. And find the median number of days with above average temperatures. Okay. So we're going to write these in order from least to greatest because it's going to make it easier to find the median. So we wrote the days of the high above average temperatures in order from least to greatest. And now we can find the median because median is the middle. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1, 2, 3, 4, 5, 6. Right here is the median. But since I have 2 numbers, I'm going to add them together and divide by 2. So what is 9 divided by 2? Good. 4.5 is our median. Okay. Number 5 says collect data from your classmates about the amount of time that each person studied for the last test and the grade they received. So we just collected our data, how much time they studied and what grade they earned. And now we're going to make that into a scatter plot. So copy these values down and then we'll make the scatter plot. So we've made our scatter plot and we're just going to plot the information now. So the person that studied for 2 hours, this is my time in minutes, got an 85. So I'm going to put a dot right there for 120 minutes and 85%. And then 1 hour is also an 85. And 10 minutes was a 75. 30 minutes was a 65. 15 minutes was a 90. 30, 85, and an hour, 70. Okay, so by looking at our graph, is there any correlation to the time studied and the grade earned? No, there's no correlation in this graph. The data seems to be straight up and down. It all stays in this one little section for grades, but the time is all over the place. So we don't have any correlation with this data. All right. Okay, so that's all we're going to do for today. And let me know if you have any questions.